I remember the moment I first understood that Voyager 1 would die alone. Not metaphorically, actually alone. In a universe so empty that even the memory of light will have faded. I was reading this paper by two astrophysicists, Fred Adams and Gregory Laughlin, who spent years calculating what happens to the universe when you fast-forward it past everything we think of as time. And buried in their math was something I couldn't stop thinking about. At times exceeding around 1 to 10 trillion years, the supply of interstellar gas will be exhausted. Yet star formation will continue at a highly attenuated level via collisions between brown dwarfs. By then, Voyager will still be out there. Silent, frozen, forgotten, still moving, and the universe around it will be dying. That's when I realized this isn't just a story about a spacecraft. This is a story about what it means to outlast everything. Voyager 1 will reach one light day from Earth in 2026. Right now, in 2026, it sits more than 25 billion kilometers from us. Commands sent to Voyager 1 now take about 23 hours to reach the spacecraft, and the shutdown process itself takes about 3 hours and 15 minutes to complete. We're speaking to it across a gap so large that light itself needs a full day to cross it. And every second, that gap widens. Voyager isn't slowing down. It's been traveling away from Earth on the same trajectory and at the same speed, 38,000 miles per hour. Earth, since its flyby of Saturn in November 1980. Since the probes began flying nearly half a century ago, they've been losing an estimated 4 watts of power per year. Its radioisotope thermoelectric generators may supply enough electric power to return engineering data until 2036. Voyager 1 still has 2 remaining operating science instruments. Quote, one that listens to plasma waves, and one that measures magnetic fields. Engineers are shutting down everything non-essential, turning off heaters, sacrificing instruments they spent decades building, just to squeeze a few more years out of a machine that was supposed to last 5, which, when you really think about it, changes everything. Because Voyager wasn't designed for this. It was built to visit Jupiter and Saturn, snap some photos, and transmit them home. 5 years, maybe 10 if they got lucky. That was the mission. But gravity had other plans. Voyager 1 crossed the heliopause and entered interstellar space on August 25, 2012, making it the first spacecraft to do so. It punched through the edge of the sun's influence and kept going. And now it's flying through a region of space where no human-made object has ever been. But here's the part most people skip. Voyager isn't just exploring interstellar space. It's entering a timeline we can't follow. Around the year 2036, maybe a bit later, if engineers get creative, Voyager will stop answering. Not because it broke, because it ran out of power. The plutonium inside its generators will have decayed too far. The instruments will go cold. The transmitter will fall silent. And from our perspective here on Earth, Voyager will simply vanish. We'll send a command into the dark and hear nothing back. The last signal will arrive, and then there'll be no next one. But Voyager itself? Voyager will still be moving, and this is where the story stops being about engineering and starts being about something much stranger. Voyager 1 will pass within 1.6 light-years distance of the star Gliese 445, currently in the constellation Camelopardalis, in about 40,000 years. By then, every person who worked on the mission will be dead. Everyone who watched it launch will be gone. The languages we spoke when we built it may no longer exist, but Voyager will drift past that star, close enough that if anyone were watching from a planet there, they might see it as a faint speck against the black. But 40,000 years is nothing. Within 1 billion years, Voyager will get to the opposite side of the Milky Way disk relative to the Sun. Think about that for a second. Our own galaxy is so vast that even moving at 38,000 miles per hour, it takes Voyager 1 billion years just to cross it. By the time it gets there, the Sun will boil off all oceans on Earth, making it uninhabitable. Earth will be a scorched, lifeless rock, and Voyager will still be traveling. And here's where I want you to slow down with me, because this is the moment where human intuition completely fails. We think of deep time as ancient history, dinosaurs, the formation of the Earth, the birth of the Sun. We look backward. But Voyager forces us to look forward into a future so distant that the things we think of as permanent, stars, galaxies, light itself, start to break down. Most people hear this and immediately move on. Don't, because what happens next isn't just big, it's cosmologically significant. Stars are expected to form normally for 1 to 100 trillion years, but eventually the supply of gas needed for star formation will be exhausted. As existing stars run out of fuel and cease to shine, the universe will slowly and inexorably grow darker. The smallest stars, red dwarfs, can burn for trillions of years. Recent astrophysical models suggest that red dwarfs of 0.1 solar masses may stay on the main sequence for some 6 to 12 trillion years, gradually increasing in both temperature and luminosity, and take several 100 billion years more to collapse, slowly, into a white dwarf. But even they don't last forever. By the time 10 trillion years have passed, futely, roughly 700 times the current age of the universe, Fist, the last red dwarf, will flicker out. Star formation will have ceased entirely. Galaxies will be graveyards, filled with the cold remnants of dead stars, white dwarfs, neutron stars, black holes. The cosmic microwave background, the faint afterglow of the Big Bang, will have redshifted into insignificance after several trillion years. And Voyager 1 will still be out there, older than nearly every star that will ever shine in the Milky Way. Let that sit for a moment. Think about what that means. Voyager was built by a species that evolved on a planet orbiting a star in a galaxy full of light. It carries a golden record etched with sounds and images from a living world. The pulsar map on its cover shows the location of the solar system with respect to 14 pulsars, whose precise periods are given. Each pulsar has its own signature pulse rate, making them easy to identify and ideal as reference points on a map. It's a message designed to say, "We were here. This is where we came from." But by the time the stars go out, that map will point to nothing. The pulsars will have slowed, drifted, died. The Sun will be a cold white dwarf, if it still exists at all. Earth will be long gone, and the record itself, gold-plated, carefully engraved, never will be the only evidence that any of it ever happened. Both golden records are highly likely to survive, at least partially intact, for a span of over 5 billion years. But 5 billion is still nothing. compared to 10 trillion. At that scale, even the gold begins to erode. Cosmic rays, the occasional collision with a molecule of interstellar hydrogen, the slow grinding of deep time. Eventually, Voyager won't look like a spacecraft anymore. It'll look like debris, a lump of metal tumbling through the void, its purpose erased by entropy. And if the universe allows it, son, if proton decay is real, if the math holds, son, nearer, then even that lump will begin to dissolve. The evolution and eventual sublimation of degenerate objects is dictated by the decay of their constituent nucleons, and this evolutionary scenario is developed in some detail. The atoms that make up Voyager, the aluminum and titanium and copper, will slowly break apart. Not from heat or collision, from time itself. At some point, Voyager stops being a thing you could touch. It becomes a cloud of particles, then a whisper, then nothing. But even that assumes we understand how matter behaves over those timescales. And, honestly, we don't. The models break down. The physics becomes speculative, which means there's a strange, uncomfortable possibility that Voyager might outlast even our ability to predict what happens to it. And here's what I keep coming back to. Voyager will witness the end of the Stelliferous era, hormone, the age of stars. It'll drift through a universe so cold, so dark, so empty, that the concept of day and night will no longer have meaning. There will be no sunrises, no starlight reflecting off dust clouds, no galaxies glowing in the distance, just black and silence. And Voyager, still moving, still obeying the laws of motion it was given in 1977. Somewhere in that darkness, it'll pass through clouds of hydrogen so diffuse that a single atom might occupy a cubic meter of space. Molecular clouds have so much mass concentrated in one place that they may act to bend the trajectory of the spacecraft and fling them into new orbits, and sometimes much farther out, sometimes even deeper toward the galactic core. Its path will shift, unpredictably, as gravity tugs it one way or another. It might get flung toward the center of the Milky Way. It might get ejected entirely. We'll never know, because by then there'll be no one left to calculate its orbit. And that's the loneliest part. Voyager isn't alone because it's far away. Voyager is alone because it will outlive the very idea of companionship. It'll outlive us. It'll outlive Earth. It'll outlive the sun. It'll outlive the stars. By the time its journey ends, real, if it ever ends, there'll be no witnesses, no one to see it arrive, no one to decode the golden record, no one to understand what it was or why it mattered. And yet I think there's something profoundly beautiful about that. Because Voyager wasn't sent into space to be remembered. It was sent to explore, to go farther than anything we'd ever built, to carry a piece of us into a future we'll never see. And in that sense, it succeeded beyond anything its designers could have imagined. It's the farthest thing humanity has ever touched. It's the oldest traveler we'll ever know. And when the last star fades, and the universe grows cold, and the long night begins, Voyager will still be moving. Not because it has a purpose, not because anyone is watching, but because that's what it was built to do. To keep going. To never stop. And maybe that's enough.